Deploying a model like Anthropic Claude at scale is absolutely not a simple software purchase anymore. Right now, it introduces some severe financial variables and compliance boundaries that can completely dictate whether your project actually survives. So in this explainer, we are tearing down the hidden friction points you need to know about to avoid some catastrophic scaling traps. Our blueprint for today covers a lot of ground. We'll start with the enterprise scaling conflict and procurement economics, and then work our way through deployment optimization, security gaps, integration friction, and finally lock down a tactical enterprise implementation framework.
Section 1. The enterprise scaling conflict, navigating the token unbundling pivot.
$1,104,000. Take a second to process that. This figure represents the projected annual operational cost for an 800-user deployment under Anthropic's decoupled enterprise tier structure. What starts off looking like a totally predictable operational expense rapidly metastasizes into a massive consumption-based liability.
Let's actually run the numbers to see how this happens. Say you keep 800 users on a bundled team plan at a flat $25 a seat. Your annual cost, a very predictable $240,000. But if mid-market organizations scale past that 150-user cap on the team plan, you are forced into the unbundled enterprise tier. At that point, you're paying a base license of roughly $192,000, plus totally separate usage-based token API billing. For a mid-case scenario, that tacks on over $900,000. Just like that, your predictable $240,000 expense blows up into a $1.1 million reality.
Section 2. Procurement economics and unbundling. The business tier taxonomy.
To avoid that exact kind of financial shock, you really have to understand your total cost of ownership by looking closely at Anthropic's very rigid business tier taxonomy. Notice how the enterprise landscape strictly partitions into seat-based subscriptions on one side and consumption-based API access on the other. It scales purely according to your operational volume. You've got individual tiers like Pro sitting at $20 a month for a 200K token context window. Then you have these heavy developer tiers, Max 5X and Max 20X, pushing up to $200 a month. On the organizational side, Team Standard offers a flat $25 a month, but remember, it caps aggressively at 150 users. Team Premium jumps up to $150 a seat. And finally, you have the Enterprise tier. This unlocks a massive 500K to 1 million token context window, but it throws you right into that custom pricing and unbundled API billing trap we just broke down.
Section 3. Deployment and technical optimization, cloud frameworks and context execution.
Once you get through procurement, scaling your infrastructure means choosing between first-party console access or going through a third-party cloud partner. Deploying through managed cloud platforms dictates your data residency and your operational limits. Comparing AWS Bedrock and Google Vertex AI reveals some really distinct architectural differences. AWS enforces a strict 20 megabyte payload limit. It authenticates via IAM roles, and it uses Bedrock knowledge bases for its search layer. Google Vertex AI, on the other hand, gives you a slightly larger 30 megabyte limit, uses GCP service accounts, and leverages Vertex AI's search. Also, you have to watch out for endpoint routing. Global endpoints dynamically route traffic for uptime with no premium. But if your compliance rules demand multi-region or strict regional endpoints for geographic data compliance, that imposes a strict 10% pricing premium on your API usage.
This brings us to a huge technical bottleneck, context window bloat. The fix for this is the Model Context Protocol, or MCP. Normally, if you wanted to move data from Google Drive to Salesforce, you'd have to load the entire file into the AI's context window. That burns through tens of thousands of expensive tokens. MCP is a total game changer because it acts as a gateway, letting the AI bypass those traditional data loading mechanisms completely. The agent just writes a localized script to move data directly between those external servers. The file never actually touches the model's context window, which radically reduces your token consumption.
Beyond MCP, look at the incredible financial impact of prompt caching. Recursive agent workflows constantly reprocess conversational history, meaning your costs can easily explode. Anthropic mitigates this by storing stable blocks of context on their servers. Cache writes do carry a 25% premium up front, but any subsequent cache reads get a massive 90% discount. The math here is undeniable. For a 10-turn session over a 30,000 token codebase, unoptimized rates sit at 90 cents. But with prompt caching properly configured, that exact same session drops down to 17.5 cents. That engineers an 80.5% financial reduction.
Section 4. Security gaps and compliance, HIPAA BAA limitations.
Of course, all that optimization means absolutely nothing if your system fails on compliance. Out of the box, Claude is not HIPAA compliant by default. To process protected health information, you have to execute a formal Business Associate Agreement, or BAA. But the standard click-through BAA is highly restrictive, and administrators have to navigate this exact matrix. Core chat, projects, and voice search are fully covered, but you hit hard exclusions with things like Claude for Office, meaning your Word, Excel, and PowerPoint add-ins. Those, along with the Chrome extension, are explicitly not covered because the data routes through beta integration pipelines.
Here's where it gets really complicated for healthcare organizations. To use Claude Code under a BAA, administrators are mandated to implement a custom sales-negotiated zero data retention, or ZDR, configuration. But that creates a massive operational paradox. Highly regulated organizations are frequently required to use specific covered models, like Fable 5 or Mythos 5, which legally mandate a 30-day data retention window strictly for auditing purposes. You literally cannot have zero data retention and a 30-day retention window at the same time. Because of this, healthcare organizations are structurally blocked from simultaneously using Claude Code with those covered models.
Section 5. Integration friction and hallucinations, structural ecosystem failures.
Even beyond compliance, you have to factor in structural architectural debts when comparing Claude's standalone setup against mature ecosystems. Let's look at Microsoft 365. Claude operates primarily as an external workspace. Its desktop co-work application actually operates locally right on the user's machine, meaning it creates and saves file versions locally. This introduces severe local file creation risks, and worse, it completely bypasses enterprise-level Microsoft Purview data loss prevention policies. Compare that to Microsoft 365 Copilot, which executes Claude natively strictly inside secure corporate tenants. Relying on Claude's desktop app introduces a very real risk of accidentally exposing highly confidential organizational data.
38%. Even with constitutional AI actively guiding its alignment, Claude still presents significant analytical vulnerabilities. On the AA Omniscience benchmark, Claude's Sonnet 4.6 registers a 38% hallucination rate. Now yes, that is mathematically superior to competitors like GPT 5.2, which hits around 78%. But a nearly 40% error rate in highly regulated data environments, that is still a massive operational liability.
To mitigate that nearly 40% error rate, enterprise deployment teams absolutely cannot rely on the model's default behavior. You have to architect strict verification workflows that forcefully override the model's confidence. This means using system prompts to enforce uncertainty responses, literally forcing the model to say, "I don't know," when its confidence drops. You have to mandate direct word-for-word quoting for document extraction before any analytical tasks begin. And you need to implement iterative refinement loops to constantly cross-examine the initial outputs.
Section 6. Tactical Enterprise Implementation Framework, System Gates for Deployment. Enterprise buyers must execute a chronological, strategic resolution to stabilize all these compliance protocols and expenditures. This 5-step framework is derived directly from the source data. Step 1. Delay the unbundled enterprise trap by maxing out that 150-user team standard cap first. Step 2. Optimize your mixed seat allocations. Deploy the $100 premium seat strictly for your developers and $20 standard seats for your business users. Step 3. Enforce sovereign data isolation by routing your traffic strictly through an AWS Bedrock Virtual Private Cloud. Step 4. Optimize context by deploying prompt caching to secure that massive 90% read discount. And Step 5. Standardize all your ecosystem connections through the Model Context Protocol to unify your integrations and eliminate custom API pipelines.
The mechanics of deploying generative AI at scale require absolute mastery over its financial thresholds and its structural friction points. Take these tactical steps back to your engineering and procurement teams right away, because the architecture you choose to build today is exactly what will dictate your enterprise survival tomorrow. So how will your organization navigate the unbundling trap? V Packaging Blueprint, thumbnail and on-screen visuals. Thumbnail text hook, the $1 million Claude trap. Thumbnail visual concept, a minimalist, high-contrast layout, a pitch-black background with a single, sharp, high-end 3D focal element, a glowing, shattered Anthropic logo integrated into a rising red financial graph. The text overlay is stark white and blood red. Key graphic assets, Graphic 1, Slide 9 integration, a system diagram overlay showing AWS Bedrock versus Google Vertex AI request payload limits and RAG layers. Graphic 2, Slide 10 integration,
A flowchart visualization of the Model Context Protocol, MCP, bypassing the context window to execute code directly between Google Drive and Salesforce. Graphic 3, Slide 11 integration. A mathematical overlay of the prompt caching cost equation, calculating the drop from 90 cents to 0.175 cents.